Hi guys, Ashwin here. This is episode 7 of Sui Deep Dive series, and today we'll be looking into Kiosk, as mentioned in the previous episode, and Kiosk extensions. Some new concepts we'll be learning today, and some prerequisite concepts that we need to cover in the upcoming part of this exact part 1. We will divide it into two parts, this exact module implementation, because it needs to be some concepts needs to be covered for you guys to understand the module next module that we will be building, right? So those concepts would be like publisher objects and what is bag, bag struct and move, and then later on we will jump along how we can add rules to the transfer policies, and yeah, how we can exactly create some transfer policies for ourselves and transfer policy cap with just explained here. And then in the next part we'll cover along how we actually implement it in the code base, so that you guys can understand the concepts first, and then when we just see the code, it will be very useful for you guys to understand it very quickly, better than going along the code and explaining the concept one by one. Yeah, let's get started. So let me get started with Kiosk. What is Kiosk and Kiosk extension, right? So as we have discussed about Kiosk in the previous video, we will be discussing what is Kiosk, and we'll just revise what is Kiosk, and then we'll jump into Kiosk extensions and why we need Kiosk extensions, right? So when we understand Kiosk more in clear fashion of how it works, and then as we discussed previously, we just go in depth, or the points that we have left out, we cover it in the Kiosk, and we just see why we need Kiosk extension, so you get a better understanding of the both, right? So let me say this is the Kiosk. Okay, this is the normal Kiosk structure, right? And it's going to have some fields over here, and and obviously a balance field. We discussed why this balance field is needed, right? So let me say I have a person one buying some assets from this kiosk, which is an NFT inside the kiosk itself. So what happens is we make a purchase from the kiosk, and that exact coin that we are giving, or that coin that we spend on that exact asset, will be stored in this exact balance field, so that this exact kiosk owner only can retrieve the balance or withdraw the balance out of the kiosk. Okay, so this is the centric approach that we have discussed in the previous video. Just I am recalling it now. Okay, this is totally a centric approach. So when we discuss some flexible applications, say we can implement this thing for a OpenSea kind of application, where an individual creator can have his own kiosk and have assets, have his collections of NFTs stored inside the kiosk, and he can make sure that whoever is purchasing the NFT spend some money on it, or follow some royalty policies that we already discussed in the previous video. And he buys some NFT, and then that exact amount is only took out of the kiosk by himself. Okay, this can be useful for OpenSea kind of application. Let's say there is an application, say we have an auction platform kind of application. Okay, so one item in the sense, or for instance a sofa set. Okay, that exact sofa set is a kind of an unique asset, right? So in our blockchain world, we name it as NFT asset. We have it as NFT asset. So for that ownership of that exact sofa, we just have an NFT. Okay, and I'm going to auction that product out. Okay, so what I'm going to do is, so in the previous OpenSea platform that we discussed, any user can come and create his own kiosk, and put in assets of them, put in assets that he want to sell it to the ecosystem, and he gets money out of it. That is a thing that we discussed. So let's say we have another application where you can have multiple entities involved to have to store multiple assets inside, inside assets, and it has multiple interactions, right? So, and also the amount is going to be something only the kiosk owner can't only yeah, according to the kiosk approach, you make sure that the kiosk owner only can retrieve the balance out of it, right? So let me say I have another kind of application where you need to pass that balance amount to multiple members. So you are not the only owner in the application. For instance, in the auction example, I am auctioning out an sofa and it's being purchased by another guy, and multiple others keep an auction set like that. Okay, so that exact auction that that I have placed in the platform, you pay some amount and you buy that asset, right? So I am the only guy should get the balance out of it, right? So that should be the thing. But in the centric approach of kiosk, only the kiosk owner can get the balance out of it. So what we can do is we can now use kiosk extensions. Previously also we will be using kiosk extension. I will tell where. So kiosk extension gives multiple capabilities, like not to mention capabilities, multiple functions. So it gives access to a storage space where you can have the assets stored inside that storage space. Okay, so let me say I have a kiosk extension enabled or installed on the kiosk. Okay, so what kiosk extension will make sure is it can give you multiple functions, say what to say, the exact things that kiosk can't do, you can have that as enabled for kiosk by installing some extension. It's not an actual extension, it's some set of rules you can assume. Okay, set of rules you can assume. Let's say that we have previously discussed, I get the storage space, right? So in that exact storage space, it's going to be of type bag, in the struct bag, which is like a basic type in Move. Okay, it's a collection type. And what I'm going to do is I'm going to store the assets in a key field pattern. Okay, and because kiosk itself doesn't have the ability to store any type of assets inside, you need to have the kiosk extension to make sure you get access to this kiosk extension, sorry, storage space. Okay, that is one thing. So we got the storage space, right? Now let me say that we have previously discussed about how we store assets inside the kiosk. That is something we discussed with the storage space enabled. Let's say that we discussed in the centric approach of kiosk, you can also only the kiosk owner can place the asset or list the asset or take the asset or delist the asset, everything. So let me say I want the control to be given to others as well. So what I can do is I can make sure that I can use kiosk extension to apply those rules to the set of users involved in that application, right? Using kiosk extension I can do that. So that is one thing. And another thing is here in the balance field, so in the kiosk itself, instead of storing the profit, I have another key field, key and field. Okay, so not key, sorry, key and value pair. Okay, so key and value pair, what I am going to do is I have a balance key and field value as the balance stored, the coin type that is getting stored for each asset that is being bought from the kiosk itself. So that what I can do is I can access this storage space and get the balance out of it and give it back to the user. So this is the approach that I've been talking about. So we have discussed about the kiosk extension in a brief way, not in brief way, because we need to see the module implementation to actually understand how we use kiosk extensions to make sure we use the storage space that it provides, or like the placing function, placing the asset, or taking the asset out, or listing the asset out for sale, and locking the asset out, everything. So another one basic thing is, so when we enable kiosk extension, we get the storage space, right? So when we do that, it is of type bag, right? So what is bag type here? So let me say, so this is struct bag, okay? So this exact bag is going to have a size field as well, and another field here, okay? We'll just focus on the size field now. Okay, we'll just focus on the size field. Now what we are going to see is why bag is used in the storage space function. You when you make sure that you are having a kiosk application, it is not very specific that you are going to store type specific struct or objects inside any object, inside any structure, you can say. So it's going to be something not homogeneous, it's going to be heterogeneous, right? So bag is very specialized to store heterogeneous values, key value pairs. So how it's going to look is, say this is the bag that we have discussed. Not exactly, this is the exact bag implementation. And let me say I have struct simple something, and say something field 1. It's going to be of type bag here. Now what I'm going to do is, it's going to be type bag. So that exact field 1, how can I access, or how can I store something inside that bag is, say it's going to be inside field 1. This is the field name, and simple, that is struct field 1, and it's of type bag, right? So I can call a function, say something like bag add, probably we will see in the next module in depth. So what I'm going to do is, this is the storage area, which is bag, and then you pass in the key name, and then you pass in the value associated with that key. Okay, so this is how the structure is going to look when we store something in the bag itself. So this exact bag is going to have lots of heterogeneous values, and size, how many heterogeneous key values is stored in the bag, can be calculated from the key field itself, sorry, from the size field that I have discussed previously. So let's say this is the bag, and it's going to have lots of key value pair, key value, okay? This is how the bag structure is going to look, and we'll implement it in the module, and you will get a better understanding of bag, why we are using bag, okay? So this is one thing. So now we'll discuss about the publisher object. So we discussed about bag, right? So let's discuss publisher object now. So let me say this is the module that we are creating. So what is the exact difference between publisher object and or some authorization caps that we'll discuss first? Auth caps like owner cap or admin cap. So when we talk about publisher object, we use the one-time witness inside the module to create a publisher object once, and you pass that publisher object to the deployer or the contract creator or module creator. Then you use that publisher object to determine whether the exact type inside inside the module belongs to that exact package or module, okay? So you use this publisher object to determine it, and you also make sure that you can use this publisher object as an authorization cap as well. If you need to access some public or entry function, you can have the first argument as the type publisher, and that exact module knows which type of publisher or it requires, right? So it knows it. So when the owner pass in the publisher object only, he can access the exact entry function that we are talking about. These two things can be satisfied with publisher object. Okay, so this is the first thing that I wanted to discuss. So let me just show it in action. For instance, let me just show it in action. Say this is of struct type, okay, type 1, something simple example. What I can do is I can have a assert statement, say this exact type 1 belongs to something like you'll have it in the module, belongs to this exact module or package. We can have a assert function inside the module. Okay, so it's going to be like something looking like for instance, if I'm taking the argument name as publisher or just pub, okay, I'm taking in publisher and I can call something like assert whether this exact type I'm passing in belongs to this exact module. This is the thing that I have discussed about. You can make sure that that exact publisher object can vouch for this exact type. Okay, but you can't do that in the authorization caps that we discussed previously in other videos. But also you can use that publisher object to act as an authorization cap, right? So that is two things that we need to discuss. So we have discussed. Okay, so this is one thing, and next up we also need to look into what is transfer policies that we have previously discussed, and requests that you create when you know purchase some kiosk, and you use the transfer policy to agree to that exact request so that you complete the purchase and then you buy the asset outright. So that is something we discussed in the previous episode. So let me give an intro, or let me give a revision about it so that we can jump into it. So let me say this is the transfer policy. You should, so when we need a transfer policy, you call some function. That exact function needs the publisher object as well. So that only I am discussing what is publisher object now itself, because we will be seeing it in the upcoming module that we are going to write. Okay, you use that publisher object and as well as the exact kiosk which the transfer policy is going to get created. Okay, and you get the transfer something like transfer policy new, I guess. You pass in the publisher and kiosk inside, and you get the transfer policy and as well as the transfer policy cap. You use the transfer policy cap to modify the transfer policy, and you make the transfer policy a shared object, and you have the transfer policy cap as an owned object, so that only certain people can access the transfer policy and add some rules to it, right? So we also discussed about the rules that we will be applying for the transfer policy as well. Say if I'm going to make a purchase from the kiosk, and if you are buying some asset from kiosk, in my application I am going to make sure that I apply some royalty rules to it. So I add the royalty type to it, and if the royalty type is just succeeded, the rules that I mentioned is succeeded, then the request that you are making can be verified by my transfer policy, and says that the transfer policy that you have given is approved, that is like the rules are applied, so that you can make sure that asset is given to you, the asset is transferred to you. That's how we do it, right? So how this works is like, since we also know that NFTs are something like, you don't have the store capability, right? We have the store capability because we are talking about the Soulbound NFT, my mistake. So in our case it is transferable. So yeah, these are the things that I need to discuss with regards to the transfer policy as well. And So now let's just continue or just give a quick intro for the next part of what we are going to discuss. So next up, what we will do is we will create a module where only it's going to be a two bidder system. Okay, very simple approach, but it is useful for us to understand the whole kiosk application that we have discussed in the previous two videos, which is going to be of which is from episode 6 and episode 7 part 1, and I'll have it as episode 7 part 2. Okay, so this is the module implementation for the part 2, which is the continuation of from 6 7 and 7th part 2. So how it's going to look is, it's going to be a two bidder system where two bidders is going to bid for a single asset inside the kiosk, and that exact asset is going to be placed by any individual outside of the application. It's going to be of any type, and whoever is going to make a highest bid is going to, out of the two bids, it's going to happen within 24 hours. That exact single bid is going to take the asset out of the kiosk and own it for themselves. So we are not going to have any external rules applied. We just have a simple transfer policy, with auction witness. Auction witness is the name of the witness that I'm going to create in the module. And yeah, this is going to be the module that we'll be implementing in the next part. Yeah, let's see in the next part then. Thank you.